Hi guys, it's Dalton here from Comm Advantage, and I'm going to talk to you about annuities. So annuities fall under this umbrella with the idea behind time value of money. So if you haven't already watched the time value of money video, go back and do that now so you have some of that foundational understanding and then come back to this video. Annuities are going to be super common throughout all of our finance courses. So what is an annuity? An annuity is a series of cash flows in or out that start at time one, and they're going to be the same amount each time. So whatever we're dealing with, in this case $100, we're talking about that money going in or out starting a year from now. What we're often interested in with annuities is the present value, meaning what is this worth at T0? How do we figure out how much that entire string of cash flows is going to be worth in today's dollars, right? Remember, present value is always today's dollars. And so the formula you're provided with, we've got here, can look a little intimidating, but you're going to end up using it a lot. So that present value, that PV, is equal to C, which they often call the coupon rate, but all we're really talking about there is that cash flow per period. R, as we've seen before, is our interest rate. And an important thing here is that these two things have to match, okay? So if we're doing an annual payments, we need to make sure that that interest rate is annual. If we're doing monthly payments, we need to make sure that interest rate is monthly. So you might have to divide there a little bit. And remember that T is that number of periods for which this is going to be occurring. So this formula is always going to find us the present value one period before whenever those cash flows start. So what's our present value of receiving $100 annually for 4 years if we have a 5% annual interest rate and we receive the first payment at the beginning of year one? So that's the timeline we were just looking at there. They're not going to tell us this is annuity. We have to know, hey, I'm looking at an annuity and I want to find that present value. So I've got my annuity formula and I'm going to say, hey, yeah, okay, I know that the amount of cash I'm getting each time is $100, that my interest rate is 5%, and I'm going to multiply this by its compounding factor here. So 1 plus that interest rate. And I really encourage you not to put the 1 plus into your calculator. Simplify your life and just, right away that that's 1.05. And this is happening for 4 periods. So it's got an exponent there of 4. And so what this is going to tell us is that the present value, the value in today's dollars of this future money, when you look at that, we're like, hey, $400, but taking into account interest rate, it's only worth $354.60. So all of these cash flows today, we would be basically ambivalent between whether somebody gave us $354 today and we could invest it ourselves, or if somebody paid us $100 each year for 4 years starting a year from now. Annuities, though, sometimes in the problems, it can be a future annuity. So what happens if instead of getting that first payment a year from now, which is kind of the default setting, we're getting that first payment at the beginning of year 2? So remember that anytime we use the annuity formula, it's going to take that string of annuities that in this case are starting in year 2, and it's going to tell us that present value in the period before those cash flows start. So in this example, if we use that formula, it's going to give us the value at year 1. And we actually know what that is, right? We just found out that it would be worth that $354.60. But that's not really what we're looking for in this problem. We want to figure out the actual present value, and present value is what's occurring at T0 there. So in order to do this, we're going to discount back that $354 just using our basic time value of money situation there. So the actual present value in this situation Yeah, we've got that $354.60 at T1. But if we go back one more period, so we would divide by our interest rate, we figure out, hey, when we discount that back, it's going to be worth $337.71. So sometimes you have to combine one formula with just our general time value of money knowledge. We know that we can take a lump sum and move it forward or move it backwards. And in this case, it's just us going backwards from T1 to T0. And if we understand what's going on in the problems and we understand that the annuity formula, that this awesome formula that we have is going to tell us the value one period before the cash flow starts, it's easy to move it around. So the other way that that happens is called an annuity due. And an annuity due is just an annuity where the first payment occurs at time 0 instead of time 1. And this is so common that it has its own name, annuity due. So we know for a regular annuity that cash flows are going to start one period after the problem starts. So they start at basically time 1, whatever that is, month 1, year 1, day 1, depending on the problem. And so what's happening in annuity due is all of those payments are shifting back. And we're getting our first payment today. So that's all that's really changing here. So when we do this, previously our formula would have been this present value 1. And again, we know that the annuity formula, so this is just our regular annuity formula, finds us the value one period before whenever this cash flow starts. So if I use this formula, it would actually find me the present value at time -1. And that's not what I want. When I'm talking about a present value, again, present value needs to be at T0. So for an annuity due, the formula is the same, right? When we look at this, we've got the same one formula, and then we just have this extra term. And all this extra term is doing is going forward. We know that the regular formula would have found it one period before when those cash flows start. And so we're finding that lump sum, and we're going one period into the future, back to T0. We're discounting it forward. We're applying that interest rate to figure out what's that present value in today's dollars, okay? So in this situation, if we wanted to calculate this out, right, we know that the future value from before, right, was at $354.60. Just want to show you where we got that, right? But that $354.60. And again, that's not the present value we're looking for. So we're just going one period into the future there. So we're taking that $354.60, that's the present value, but the wrong present value, and we're bringing it forward, applying that interest to figure out, hey, what is my present value today? And I didn't calculate this, so I'm going to do that real quick. And so in this situation, it's worth $372.33. So let's put a little bit of this into action. So we've gotten a puppy, yay! And we want to make sure that we have all the money we need for their annual checkup. The vet has said that the checkup will cost $200 for the next 15 annual visits. You are able to invest your money at an average rate of return of 6.2% per year, and their first checkup is today. How much do you need in your account today to cover all future costs? So a couple of things to take away here, okay? We're talking about a cash outlay, so we're spending $200 each time for 15 visits. We can invest that money and we get our rate of return, that R of 6.2%. And their first checkup is today, meaning that this is an annuity due, that we're spending that money today. That first cash flow is right now. How much do we need today to cover all future costs means that we're looking for the present value. So for our puppy situation here, I always like to draw out our little timelines, right? At year 0, we're spending that $200 and we're going to do that again and again. And we're going to do it for 15 visits. So watch, because we're not going to year 15. We're only going to year 14. Because the first one started at 0, the last one of those 15 visits is going to be at year 14 there. Oops. So our formula here for our annuity, a basic annuity would have been that cash flow rate divided by our interest rate, 1 plus 1 over our interest rate for however many periods apply. But because this is an annuity due, remember this formula would have found us the value at -1, and that's not what we're looking for. We bring it up 1 period by multiplying it by 1 plus our interest rate. We're just bringing it forward to that time 0 because the present value is always time 0. So with the information that we have here, our cash flow is going to be that $200. Our interest rate is that 0.062, 1 plus 1 over 1.062, and this is happening for 15 periods, okay? So while my picture says 14, we know that there were 15 visits happening, okay? 1 plus that 0.062, and remember, that end term, that 1.062 that we're multiplying, is just us going from -1 to 0. Because that first payment happens at 0 and the original formula will find us the value right before that, we're just bringing it back up into today's terms. And so the value here is $2,036.19. So you wanted to make sure that you could pay for all future vet visits with the money you have today. You would need this $2,036.19, which you could then invest in the future. Thank you so much. If you have any questions, as always, feel free to email me, reach out on Facebook or something. If you need to get set up with anything in terms of extra help or support, reach out. For second year commerce, we've got BDM, economics, and finance support available. Have a great day.